In today's lesson, we'll be learning about the method of elimination. In our first example, we want to solve the linear system by elimination. We want to arrange the two equations so that like terms are aligned. We have 10x plus 4y equals -1, and we also have 8x minus 2y is equal to 7. As you can see, like terms are already aligned. 10x and 8x are like terms, positive 4y and negative 2y are like terms, and -1 and positive 7 are like terms. Finally, we want to choose the variable we wish to eliminate. You can either choose to eliminate the variable of x or the variable of y. It's completely up to you. I'm going to choose to eliminate the variable of y. If necessary, multiply one or both equations by a value so that they have the same or opposite coefficient in front of the variable you want to eliminate. Let's take a close look at these equations once again. 10x plus 4y is equal to -1, and 8x minus 2y is equal to 7. If you remember, we decided to eliminate the variable of y. Let's take a look at the coefficients. That's positive 4 and -2. These are neither the same or opposite coefficients. Therefore, we need to manipulate one or both of these equations. I'm going to call this equation 1 and equation 2. As you can see, 4 is a multiple of 2. Therefore, all I need to do is multiply the entire equation by 2. The first equation stays exactly the same since we haven't done anything to it. Meanwhile, the second equation gets doubled. Everything gets multiplied by 2. So 8x times 2 is 16x, -2y times 2 is -4y, and positive 7 times 2 is positive 14. As you can see, these coefficients are now opposite, which is exactly what we want. Next, we need to add or subtract as needed to eliminate one variable. Let's relabel our equations. This is equation 1, and this is equation 2. I've manipulated that. I've multiplied it by 2. Since we haven't done anything with the first equation, let's just rewrite it. 10x plus 4y is equal to -1. And the second equation, we've manipulated it. We've multiplied everything by 2. So that's going to be 16x minus 4y is equal to 14. At this point, you can either add or subtract these two equations. I'm going to add them. (10x plus 16x is 26x. Positive 4y plus -4y cancels out, which is exactly what we want. And -1 plus 14 is 13. Therefore, you can clearly see that we've eliminated the variable of y, which is what we wanted all along. When we eliminated the variable of y, we ended up with the equation 26x is equal to 13. Remember, if we want to isolate x, we need to get rid of this multiply by 26. To do that, we need to do the opposite operation to both sides of the equation. So we're going to have to divide both sides by 26. That cancels out, and we're left with 13 over 26, which simplifies to 1 over 2. Therefore, we've just solved for x, and x is 1 over 2. Next, we want to substitute into one of the original equations to find the value of the other variable. So let's relabel this equation 1 and equation 2. So I'm going to sub x is equal to 1 over 2 into either of these equations. It doesn't really matter. I'm going to arbitrarily choose equation 1. I haven't done anything with equation 1, so it stays exactly the same. 10x plus 4y is equal to -1. I'm going to replace the x with 1 over 2 in brackets. Everything else stays the same. 10 multiplied by 1 over 2 is 5. And now we need to isolate the variable of y, but y is stuck with a multiply by 4 and a plus 5. Let's get rid of the plus 5. To get rid of it, we need to do the opposite operation to both sides, which means we need to subtract 5 from both sides of the equation. That's going to look like 5 minus 5 plus 4y is equal to negative 1 subtract 5. Simplify some of these terms. 5 subtract 5 cancels out. I'm left with just 4y. And negative 1 subtract 5 is negative 6. At this point, we still need to isolate y, but y is stuck with a multiply by 4. To get rid of it, we're going to divide both sides by 4. Those 4's cancel out, which leaves you with just y, and negative 6 over 4 simplifies to negative 3 over 2. Therefore, we've just isolated y, and y is equal to negative 3 over 2. Let's write a concluding sentence. Therefore, the solution, which is also the point of intersection, is 1 over 2 and negative 3 over 2. Next, we want to check our solution by substituting into the original equations or into the word problem, which means we're going to do a left side, right side check for both equations. First, let's relabel this equation 1 and equation 2. And I'm going to say sub 1 over 2 negative 3 over 2 into equation 1. Equation 1 is 10x plus 4y is equal to negative 1. I'm going to replace the x with a 1 over 2 in brackets, and I'm going to replace the y with a negative 3 over 2 in brackets. Everything else stays the same. 10 multiplied by 1 over 2 is 5, and 4 multiplied by negative 3 over 2 happens to be negative 6. Therefore, 5 plus negative 6 is negative 1. And as you can see, the left side is equal to the right side of the equation. Therefore, this point lies on line number 1. We're going to go ahead and do the exact same thing for equation 2. I'm going to say sub 1 over 2 and negative 3 over 2 into equation 2. Equation 2 happens to be 8x minus 2y equals 7. I'm going to replace my variable of x with 1 over 2 in brackets, and I'm going to replace y with negative 3 over 2 in brackets, and everything else stays the same. 8 multiplied by 1 over 2 is 4, and 2 multiplied by negative 3 over 2 is negative 3. So 4 subtract negative 3 is 7. And as you can see, the left side is equal to the right side. Therefore, this point lies on line number 2. If you're solving a word problem, write the answer in words. This is not a word problem, but it still needs a concluding statement. So I'm going to say, since left side was equal to right side for equation 1 and equation 2, therefore, the solution is indeed 1 over 2 and negative 3 over 2.